The weird coincidences in the universe. Hello everyone and welcome to my channel. The universe, full of bizarre coincidences and mysterious order. From the delicate balance of the cosmological constants, to the clever fit of the sun and moon together, to the hidden traces of the golden section in astronomy, every phenomenon seems to suggest some kind of deep law. Why are dark energy and matter density so close? Why did the collision produce the solar system? Why do the sun and the moon seem to coincidentally have equal apparent diameters over the Earth? And why does the solar system happen to be in a quiet spiral arm position? Are these coincidences mere chance, or are there hidden laws at work in the depths of the universe? Each of these questions is a starting point for exploring the mysteries of the universe. Today, we will reveal 8 amazing coincidences of the universe. 1. Coincidence of collision of celestial bodies. Have you ever wondered if there is some kind of fate behind the formation of the solar system like we watch movies? It's like that feeling in Star Trek. Everything seems to have been predestined to happen coincidentally. And the reality is that the history of the solar system is indeed full of fortuitous and coincidental collisions of celestial bodies. The formation of the solar system happened about 4.6 billion years ago, when it was still a cloud of gas and dust. Scientists believe that the solar system began as a huge interstellar molecular cloud filled with gases such as hydrogen and helium, as well as a large number of dust particles. This material began to gradually collapse and clump together under the force of gravity, and at some point a new star, our sun, was born. But the formation of our solar system was not a simple process. It is full of complex physical phenomena, one of the most important aspects of which is the collision of celestial bodies. During the birth of the sun, the material in the interstellar clouds did not coalesce into planets in a smooth manner. Instead, thousands of primordial planets, or small bodies, collided and merged with each other to form today's planets. In the early stages of the formation of our solar system, small bodies in the universe, which we call protoplanets, collided on a regular basis. The collisions of these protoplanets were driven by gravity, and they accumulated material by attracting and colliding with each other. Over time, these small bodies grow larger and larger, eventually forming the large planets in our solar system. Let's talk specifically about how chance fate influenced the formation of the planets. As you may know, the differences in the composition of planets such as Earth, Mars, and Venus are actually closely related to the history of collisions between these bodies. For example, it is likely that the Earth formed through numerous collisions that eventually allowed the planet to accumulate the right materials to form the environment that is suitable for life today. But one of the most famous collision events is undoubtedly associated with the birth of the moon. If you've ever stood on Earth at night and looked up at the bright moon, it may never have occurred to you that the moon wasn't born with the Earth. The formation of the moon was a process full of coincidences, or even the product of a collision of celestial bodies. Scientists generally agree that the formation of the moon is closely related to the Great Collision hypothesis. According to this hypothesis, about 4.5 billion years ago, during the early stages of its formation, the Earth was involved in a huge collision with a Mars-sized object, sometimes called Theia. The collision was violent enough to eject the Earth's outer layers of material into space. This material then coalesced under the force of gravity to form the moon. And this collision was not just a coincidence, it could have been a decisive step. Because this collision produced material composition, coincidentally gave the moon a special composition, so that the moon and the Earth have a similar material basis, but also to ensure that the moon and the Earth's relative stability. This accidental collision created an ideal satellite for the Earth, which was able to influence the Earth's tides and stabilize the Earth's rotation, thus providing the necessary conditions for the emergence and development of life. The formation of the moon is just a microcosm of the many collisions of celestial bodies in our solar system. In fact, each of the planets in the solar system, especially the Earth, and the tilt of their rotational axes and orbits, are also closely related to celestial collisions. Take the Earth's tilt angle, for example. The Earth's axis of rotation makes an angle of approximately 23.5 degrees to the plane of its orbit, and this angle directly affects the seasons of the Earth. Many scientists believe that this tilt angle of the Earth is the result of a huge collision. During the early stages of the solar system, a larger object may have collided with the Earth, changing the angle of the Earth's rotation axis. It was this collision that allowed the Earth's seasonal changes to occur, providing more possibilities for the evolution of life. Without this collision, the Earth's seasons could have been very homogeneous and climate change would have slowed down considerably, thus affecting the diversity of life. In other words, it may all really have been fate, a celestial coincidence that shaped the Earth as we know it today. In addition to Earth, other planets in our solar system have experienced similar celestial collisions, creating the different features we see today. The planets Venus and Mars, for example, have a history filled with the imprint of celestial collisions. Mars, the red planet, once had relatively abundant water and atmosphere on its surface, but why did it lose these conditions? Some scientists believe that Mars may have had a serious collision with a larger body in the early solar system, a collision that caused the climate of Mars to change drastically, with water and atmosphere being rapidly lost, leading to the dry, cold conditions we see today. And Venus, with its extreme temperatures and harsh environment, also seems to be linked to some ancient celestial collision. Venus rotates in the opposite direction of the other planets and at an extremely slow rate. Some scholars believe that this may be because Venus experienced a huge impact event in its early days, which caused Venus to change its direction of rotation. Combined with Venus' proximity to the Sun, its high temperatures and heavy atmosphere created the extreme environment of today. From the formation of the Earth to the origin of the Moon to changes in the tilt angles of the planets, almost every planetary and celestial body in the solar system today is closely related to one celestial collision after another. And while these collisions seemingly occurred by chance, they have worked together to shape the solar system we know today as one that is suitable for life. If these collisions hadn't happened, Earth's history, and even our own existence, would be very different. And these coincidental collisions have shocked and awe-inspired scientists and astronomers. They are more than simple chance events. They are an unavoidable part of the evolutionary process of the universe. 2. Coincidences of the cosmological constant. As you may already know, the cosmological constant was first introduced by Einstein in his equations of general relativity. Einstein felt at that time that the universe was static and introduced this constant to balance the attraction of gravity and keep the universe static. Later, when Einstein realized that the universe was not static but expanding, he discarded this gravitational balance constant. Interestingly enough, a few decades later, scientists realized that the universe not only did not stop expanding, but the rate of expansion was accelerating. At this point, the cosmological constant was brought back as a key factor in describing the accelerated expansion of the universe. This makes one a bit puzzled as to why the value of this constant is so important. Its value relates to the rate of expansion of the universe, the fate of the universe, and even the fact that we live today in a universe that is suitable for life to exist. In other words, if this value were even slightly different, we might not be able to chat here. The Earth might be long gone, or have no chance of existing at all. The value of the cosmological constant is very small, yet it has a huge impact on the structure of the universe. Modern physicists have calculated that the value of this constant is about 10 to the power of negative 120 energy densities per cubic centimeter. In scientific terms, energy density is quite small. It is important to realize that 10 to the power of negative 120 is an extremely small number, close to zero. In fact, its magnitude is a coincidence, because if it were large, the universe would expand rapidly and disperse into a premature void, while if it were small, the universe would collapse gravitationally and end prematurely. The precision of this value has shocked many physicists because its existence is closely related to the evolution of the universe. Some scholars have even suggested that the cosmological constant is relevant to the question of whether life can exist. British cosmologist Stephen Hawking once said, "If the value of the cosmological constant were any greater, stars would not have formed and life would not have been possible." It makes one wonder how the universe seems to be so exquisitely designed that some mysterious force seems to be operating behind the scenes. Many scientists have wondered why the value of this cosmological constant is so precise and tiny, almost close to zero. Some have suggested that it may simply be a legacy of our current model of physics, but its coincidental nature cannot be ignored. Some researchers have even begun to suspect that the tiny value of this constant may hide deeper physical laws that we have yet to discover. There is an interesting idea called multiverse theory that tries to explain this coincidence. The multiverse theory suggests that we are not alone in the universe, but that there are an infinite number of universes, each with different physical constants and laws. In this theoretical framework, we might just be lucky to live in a universe where the cosmological constants are just right for the birth and development of life. In other words, it may be a coincidence that our cosmological constant is just right for life, because in an infinite number of universes, there will always be some that have the right conditions for life. However, as attractive as this multiverse theory is, it remains an unproven hypothesis. Many physicists do not fully agree with this theory, believing it to be too esoteric to be verified by experiment or observation. Is there a more practical explanation? One possible explanation is that the cosmological constant is not a static constant, but changes over time. Scientists have proposed a number of models to try to explain the mechanism behind the acceleration of the expansion of the universe. In these models, the cosmological constant may be related to some kind of dark energy. Dark energy is a mysterious substance whose existence is believed to be the main cause of the accelerated expansion of the universe. The nature of dark energy is still unknown, but it may be a key factor in the value of the cosmological constant. For example, scientists have proposed the quantum field theory, which suggests that every point in the universe has a quantum field that is constantly fluctuating, producing small changes in energy. This fluctuation, to some extent, may affect the value of the cosmological constant, which in turn affects the rate of expansion of the universe. At this point, you may think that these theories sound a bit complicated and even a bit out of touch with reality. However, this coincidence of the cosmological constant does have some very interesting historical stories. At one time, physicists thought that the cosmological constant was a redundant assumption. As Albert Einstein himself later commented, "The cosmological constant was the biggest mistake of my life." However, advances in science have made us realize that the cosmological constant is not superfluous, but rather an important link between the expansion of the universe and dark energy. In particular, in 1998, astronomers discovered that the universe was expanding at an accelerated rate by observing distant supernova explosions, a discovery that revolutionized our understanding of the universe. This discovery not only confirmed the existence of the cosmological constant, but also provided important clues for subsequent dark energy research. There is one more anecdote to share. When Hawking was studying the universe, he once mentioned the effect of the cosmological constant on the universe in a lecture, and he humorously said, "If the value of the cosmological constant had been a little bit larger, I probably wouldn't have needed to write so many books." This funny way of his expresses the far-reaching influence of the cosmological constant in the evolution of the universe, and also makes people sigh at the greatness of the universe and the smallness of human exploration of it. 3. The coincidence of the sun and moon. When we look up at the night sky, we often find that the moon and the sun look almost the same size, and this visual coincidence is really incredible. The diameter of the sun is about 1,392,000 kilometers, while the diameter of the moon is 3,474 kilometers, making the sun about 400 times larger than the moon. But strangely enough, they look almost the same size on Earth. Is this coincidence of the sun and moon shining together by chance, or is there some kind of inevitable reason? From a scientific point of view, this coincidence is indeed very special, and behind it lies some profound physical laws and the story of the evolution of the universe. First, we have to start with the concept of apparent diameter. The apparent diameter, as the name suggests, is the size of the sun or moon as we see it from Earth. Although the actual size of the sun and the moon are very different, their apparent diameters in the sky are very close to each other. The sun's apparent diameter is about 32 arc-minutes, a unit of view, while the moon's apparent diameter is about 31 feet 1 inch. The difference between the two is only a little bit. As you can imagine this visual coincidence, total solar eclipses are the prime example. Whenever a total solar eclipse occurs, the moon covers the sun almost perfectly, causing day to turn into night and the sun's light to be almost completely blocked by the moon. This phenomenon can only be perfected in the specific celestial system of the Earth. Why this coincidence? In fact, the root of this phenomenon is the coincidence caused by the relative distances between the sun and the moon and the Earth, as well as their respective sizes. We know that the distance between the sun and the Earth is about 149.6 million kilometers, while the distance between the moon and the Earth is about 384,000 kilometers. The sun is far away and the moon is close to us, so while the sun is about 400 times larger in diameter than the moon, because the sun is also about 400 times farther away from the Earth than the moon, they look almost the same in apparent diameter. In other words, the fact that the sun and the moon have about the same apparent diameter is a coincidence of relative sizes and distances between celestial bodies, a coincidence that creates a unique astronomical phenomenon on Earth. This phenomenon is not common in other planetary and satellite systems in our solar system. In other galaxies, the apparent diameters of the sun and the moon may be so far apart as to prevent even the spectacular sight of a total solar eclipse. You may be thinking that since this is a coincidence, it must be fortuitous. Indeed, in the context of the long history of the universe, this coincidence is indeed fortuitous because it depends on the complex relative positions of the sun, the Earth, and the moon. A total solar eclipse is a very brief and unique phenomenon that does not occur permanently, but only at a particular time in the Earth's history. Interestingly, this coincidence is not permanent. Over time, the moon is moving away from Earth at a rate of about 3.8 centimeters per year. This means that in a few billion years, the moon will no longer be able to completely cover the sun, and the phenomenon of total solar eclipses will fade away. In billions of years, we humans on Earth will no longer have the opportunity to witness total solar eclipses, which is a poignant fact of cosmic evolution. If we look at it from a larger cosmic perspective, this coincidence may not be entirely coincidental, but has some kind of inevitable law. All things in the universe, although seemingly intricate, but they are mostly subject to certain physical laws. The relative distance between the sun, the moon, and the Earth, their mass and volume, are the result of long-term evolution. During the evolution of the universe, the movements and relative positions of these celestial bodies are not completely random, and although they appear to be accidental, there may be a deeper physical necessity hidden behind them. For example, the relative positions between the sun and the Earth, between the moon and the Earth, and between the moon's gravitational force and the Earth's gravitational force, etc., which together result in almost equal apparent diameters of the sun and the moon. Some scholars believe that this seemingly fortuitous coincidence may be closely related to the conditions at the beginning of the universe. After the Big Bang, the movements and interactions of celestial bodies formed the galaxies, planets, and moons that we see today. The Earth is in a relatively special position, not only to have an environment suitable for life, but also to have this coincidental, apparent diameter of the sun and the moon, which helps us to experience amazing astronomical phenomena such as total solar eclipses. Interestingly, the phenomenon of the sun and moon together has been interpreted differently in different cultures and histories. In many ancient civilizations, the interaction of the sun and the moon was imbued with rich symbolism. In ancient China, total solar eclipses were often regarded as disasters for emperors, and legend has it that they signaled the failure of the sun of heaven. In ancient Europe, solar eclipses were often associated with disasters, wars, and other unfortunate events. Until the development of modern astronomy, people gradually understand the real reason for total solar eclipse. It is only because the sun and the moon's apparent diameter is similar, and what the fate of heaven. Disaster is not directly related. With the development of science and technology, modern astronomers have been able to accurately calculate the relative positions and movements between the sun, the moon, and the Earth. which allows us to predict astronomical phenomena such as total solar eclipses and total lunar eclipses. With the aid of satellite observations and astronomical telescopes, we are even able to calculate the location of total solar eclipses hundreds of years from now. This precise predictive ability shows that there is some kind of regularity behind the movements of these celestial bodies, which is not only the basis of astronomy, but also makes us more aware of the profoundness and mystery of the universe. 4. The coincidence of golden section in astronomy. When it comes to golden section, many people will first think of the aesthetic proportions in art, architecture, and nature, such as the Parthenon in ancient Greece or the proportions in Leonardo da Vinci's Vitruvian Man, which make people marvel at the magic and harmony of proportions. But if you look to astronomy, you will find that the golden ratio seems to exist quietly in the universe, and from time to time we feel a deep shock. In the end, these proportional relationships in the universe, is it a coincidence? Or is it a hint of some kind of deep law that we have not yet fully understood? The golden section, or golden ratio, is a mathematical constant equal to 1.6180339887, which appears in nature, art, architecture, and many other fields. The simplest definition is that if a line segment is divided into two parts, and the ratio of one part to the other is equal to the ratio of the whole to the longer part, then the ratio is the golden section. It is not just a number, but a harmonious, proportional relationship. The visual effect of this ratio is so harmonious and wonderful that almost everyone who seeks balance and beauty in design will unconsciously utilize this ratio. Scientists have even found that the golden ratio appears so frequently in nature that it seems to follow some kind of deep law in the rules of nature. So, does the golden section really exist in the universe? In the broad context of astronomy, is this ratio reflected in the stars, galaxies, and celestial bodies? Let's explore this question by starting with some concrete examples. When we look at the structure of some celestial objects, especially galaxies and nebulae, it is easy to see that the golden ratio seems to be present in some invisible way at times. For example, the famous spiral galaxies. The structure of spiral galaxies often shows a spiral shape, and the ratio of this spiral form is closely related to the ratio of the golden section. For example, the Milky Way, which is a typical spiral galaxy, the spiral arms of the galaxy show a pattern that approximates the golden section. Many astronomers have found that the structure and movement of galaxies are not random, but are governed by some kind of geometric law. This law is, somehow, similar to the mysterious relationship of the golden section. Another example is NGC 1300, a spiral galaxy, which also has a morphology consistent with the geometry of the golden section. If you look closely at these galaxies, you will see that the distance from the center of the galaxy to the periphery is almost in the golden ratio. The distance from the center to the spiral arms and the distance from the spiral arms to the edge of the galaxy happen to be in the golden ratio. Does this natural harmony mean that the golden section has some kind of inevitable existence in the universe? Perhaps some phenomena in the universe, like nature, follow a set of deep geometric laws, and the golden ratio, as the most beautiful and harmonious ratio, may be part of them. In addition to galaxies, we can also explore the role of the golden ratio in the universe from the perspective of planetary orbits. Kepler's laws tell us that there is a close relationship between the orbits of the planets around the Sun and their distances from the Sun, i.e., orbital radii. The ratio of the orbital period of certain planets to their distance from the Sun would also seem to approach the golden ratio. Some studies have shown that in the orbits of the planets in our solar system, the relationship between the distance from the first, Mercury, to the sixth, Saturn, planet and their orbital periods roughly follows the golden ratio. Although this phenomenon does not apply to all planets, this coincidence cannot be ignored. Does this mean that the formation of the solar system also follows some deep geometrical laws or physical laws that we have not yet discovered? If we look at the distances between planets, for example, the orbital distance between the Earth and Mars and the distances between the other planets, in some cases they are close to the golden ratio. While this ratio is not absolute in astrophysics, it does make us wonder, Are there certain laws of the universe that give us the sense that the golden ratio plays some unmissable role in the construction of celestial bodies? The life cycle of a star, from birth to death, also seems to exhibit patterns associated with the golden section at certain stages. The ratio between the mass, temperature, and brightness of a star tends to show a certain pattern that can also be interpreted through the lens of the golden section. For example, astronomers have found that the ratio between a star's heat and its brightness, under certain specific conditions, conforms to the golden section. These subtle proportional relationships suggest that the evolution of the universe may be following some kind of intrinsic, aesthetic, or geometric law. For example, the hierarchy is a graph used to represent the relationship between the temperature and brightness of stars, and the position of stars in this graph shows a particular distribution, which is similar to the ratio of the golden section. Although this is not the result of the direct decision of the golden section, but the regularity of its distribution makes people cannot help but think that the golden section may be the embodiment of some kind of deep law in the process of the evolution of the universe. Speaking of the golden section, have to mention the origin of the universe, that is, the Big Bang Theory. According to the Big Bang Theory, the universe began to expand from an extremely dense point and gradually formed the structure of the universe we see today. Certain studies have suggested that the initial expansion of the universe is somehow intrinsically linked to the existence of the golden ratio. The rate of expansion after the Big Bang occurred, and the subsequent distribution of matter, may have followed, to some extent, the principle of the golden ratio. This line of thought is more theoretical, but it provides us with a new perspective to think about the birth and evolution of the universe. If you look at it from a more philosophical point of view, the frequent appearance of the golden section in astronomy may suggest that there is some kind of deep design or law behind the universe. Do the proportions of the universe reveal some law of construction that we don't yet fully understand? Perhaps in a higher dimension, the universe itself is being constructed and evolving through some kind of geometric law. Although scientists have not yet been able to prove that the golden section plays a necessary role in the universe, this ratio certainly provides us with a profound sense of the beauty of the universe. Physicists and astronomers have often debated whether the appearance of the golden section means that certain phenomena in the universe are beautiful, even if this beauty is not the beauty of art as we usually understand it, but the beauty of mathematics and geometry, a kind of harmony in the nature of the universe. Harmony in the nature of the universe. Perhaps the evolution of the universe is itself a harmonious beauty, a beauty that is not limited to what we can see with our eyes, but also includes the mystery behind the celestial bodies and the laws of physics. 5. Generation of stars and planets. Life in the universe. How is life born and how does it continue on the Earth where we are? If you think about it, the answer behind this question may strike you as a hint of mysterious coincidence. In the vastness of the universe, why do we happen to be on the right planet with the right environment for life to exist? One of the answers may lie in the process of star and planet creation and the distribution of chemical elements involved. And this distribution of chemical elements does not seem to be purely random, but rather, in a subtle way, conforms to some deep law in the universe that even coincidentally shapes the birth of life. First of all, how are stars born? This is actually an extremely complex process. Stars are born from interstellar dust clouds. Millions of years ago, interstellar space was filled with gases and dust, mainly light elements such as hydrogen and helium, which gravitationally gathered into clumps and eventually triggered a fusion reaction under sufficient pressure and temperature to form a new star. And these light elements play a crucial role in the life cycle of a star. This is because, during its long life cycle, a star undergoes a fusion reaction that converts hydrogen into helium, and then helium into heavier elements, such as carbon, oxygen, and nitrogen. In this way, the star consumes fuel and gradually makes more and more complex elements. At the end of the life cycle of some massive stars, they experience a violent explosion, a supernova explosion. At this point, the core of the star explodes with enormous energy, releasing heavy elements and throwing them out into cosmic space. These heavy elements, including iron, zinc, copper, and magnesium, provided the building materials necessary for the birth of later planets and life. Almost all of the elements we have on Earth, including the carbon, nitrogen, and oxygen in our bodies, as well as the water and air on Earth, came into existence through the process of nuclear fusion in stars, or even through supernova explosions. This process is, without a doubt, a cosmic coincidence. Without the birth of stars, without their nuclear fusion reactions, and without supernova outbursts, the heavy elements in the universe could not be produced, and the basic elements needed for life could not be gathered in the right place at the right time. Then, the birth of life would have become impossible. The birth of a star not only affects the production of elements, it also directly determines the process of planet formation. After a star undergoes a supernova outburst, it releases a large amount of gas and dust, and this material begins to gather under the influence of gravity, forming planetary disks. The material composition of these planetary disks is precisely the chemical elements released by stars and supernovae, and the distribution of these elements directly influenced the composition and nature of the planets that followed. For example, the water and atmosphere of the Earth were formed by the condensation of hydrogen, oxygen, and other elements produced by stellar explosions during the formation of the planets. Even more interestingly, the planet is full of chemical elements essential for life, such as carbon, nitrogen, and phosphorus, which happen to exist in just the right proportions to form the basic substances needed for life. You can imagine the ingenious configuration of such elements. They came here through the process of stars and supernovas to make up our planet, which is suitable for life. Similarly, on other planets in our solar system, differences in the distribution of elements affect their suitability for life. Venus, for example, has an atmosphere composed almost entirely of carbon dioxide and an extremely high surface temperature, making it unsuitable for life. And Mars, although it has Earth-like seasons and climatic changes, its chemical composition and atmosphere lack sufficient oxygen and moisture for the birth of life to take place here. In contrast, the Earth, however, happens to be in a prime position, with the right temperature, abundant moisture, and just the right elements to provide all the necessary foundations for life. And how did these elements become life? This brings us to the most mysterious part of the birth of life, the origin of life. Scientists have come up with a classic model called the primordial soup theory. According to this theory, the first life on Earth may have originated from some kind of primitive chemical reaction, specifically the reaction of gases such as ammonia, methane, hydrogen, and water vapor in an environment of lightning and thunder, resulting in the formation of organic molecules, which ultimately combine to form the first forms of life. Coincidentally, the chemical elements of the universe provide the very possibility for these reactions. Carbon, for example, is highly reactive and can combine with other elements to form complex molecular structures. Nitrogen, on the other hand, is the basis of DNA and proteins, while oxygen and hydrogen are essential components of the water molecule, and water is believed to be the breeding ground for the birth of life. Without these elements, the first molecules of life may not have been created, nor would they have evolved into the more complex organisms that develop into multicellular organisms. Scientists have discovered experimentally that if ammonia, methane, hydrogen, and water vapor are mixed and stimulated by an electrical spark, simulating lightning, they are able to synthesize amino acids, one of the basic building blocks of life. This discovery, the famous Miller-Urey experiment of the 1950s, confirmed that the composition of life was not dependent on some extraterrestrial intelligence, but rather that the chemical elements of the universe, through the process of physicochemical reactions, may have given birth to life on Earth by chance. Returning to our original question, is the distribution of chemical elements a coincidence, or is there some deeper pattern? From the birth of stars to the formation of planets to the origin of life, it all seems to be one incredible coincidence in the universe at a time. All the elements that the Earth needs came together at just the right time and place to form an environment suitable for life to exist. Was it a coincidence? Some astronomers believe that Earth is not the only place in the universe where life can be born, and that although the elements and environments of other planets and star systems are different, the emergence of life may not be entirely dependent on Earth's special characteristics. Perhaps there are other places in the universe where the right environment for life lurks, or life could be born on other planets in ways we don't yet understand. However, there is another view that life on Earth is indeed a subtle coincidence, the result of a series of cosmic, interstellar, and celestial processes interacting under very specific conditions. Perhaps our existence is a miracle created by the universe at some point in time. As cosmologist Carl Sagan said, "The universe is so vast and complex that the birth of life on one of its planets is truly a very rare and mysterious event." 6. Coincidence between gravitational and electromagnetic forces. If the ratio of strength between gravity and electromagnetism changed even a tiny bit, our universe, and even our planets and life, might look very different. There is even a view that the relative strengths of these two forces are a condition for the existence of life. If they weren't where they are now, we probably wouldn't even be sitting here discussing this. Gravity is a force that we feel every day, such as the Earth attracting us to keep us from flying away. It is characterized by being very weak, but has a wide range of effects. In other words, any object with mass exerts a gravitational force, such as the apple in your hand, which attracts the Earth and the Earth attracts you. However, the strength of this gravitational force is terribly weak compared to other natural forces. But although it is weak, it is very persistent and it can act over huge distances, just like the gravitational relationship between the Sun and the Earth, where the Sun's immense mass in the universe ensures that the Earth maintains a stable orbit within the solar system, and that's the marvelous thing about gravity. The electromagnetic force is another familiar force. It is transmitted through the interaction between electric charges. Simply put, it consists of two parts, electricity and magnetism. The electromagnetic force is a very powerful force, much stronger than gravity. As an example, you may have played the static electricity trivia game, rubbing your hair with a plastic comb or a balloon, which results in your hair standing up. This phenomenon is the electromagnetic force in action. Not only does the electromagnetic force control the behavior of electrons, atoms, and molecules in the microscopic world, it also plays a role in everyday life, such as the electrical equipment in your home, wireless communication, and the propagation of light. However, unlike gravity, the electromagnetic force has two opposite effects, attractive and repulsive. Take objects with the same charge, they repel each other, while objects with opposite charges attract each other. Okay, with all that out of the way, it's time to get to the heart of the matter. Why is the difference in strength between gravitational and electromagnetic forces so important? From our everyday perception, the gravitational force is very weak and the electromagnetic force is much stronger. According to scientific standards, if we set the strength of gravity to 1, then the strength of the electromagnetic force is about 10 superscript 2 times stronger than the gravitational force, which is a huge difference, almost astronomical. In other words, one small electromagnetic force is enough to overcome the effect of the Earth's gravity. This is an astronomical level of difference, almost beyond our intuitive understanding. But, despite this, the power of the electromagnetic force does not mean that it dominates everything in the macroscopic world. In fact, the influence of the electromagnetic force is pretty much limited to the microcosmic world, at the level of atoms, molecules, electrons, etc. For example, gravity, on the other hand, is a force that can affect the macrocosm and the scale of the universe. It can affect planets, stars, and even entire galaxies. So how does the relative strength of these two forces determine the stability of the material world? Let's hypothesize what would happen if the electromagnetic force were much stronger than it is now. In such a universe, the electromagnetic force would dominate everything and might even have an effect on the basic structure of matter. For example, in this case, the electrons in an atom would not be able to orbit stably around the nucleus because of the immensity of the electromagnetic force. The electrons would be thrown out of the atom, and the matter would not be stable. In other words, the atom, which is the basic unit of matter, may not be able to maintain its existence at all in such an environment, and the material world of the entire universe may collapse. In addition, the enhancement of the electromagnetic force may also lead to excessive mutual repulsion between electric charges. Imagine that all objects in the universe, because of the electromagnetic force, would move away from each other because of the strong repulsive force, resulting in galaxies and planets not being able to form. Even the material world on Earth could completely disintegrate as a result. Without a stable atomic structure, there would be no stable existence of matter, let alone the birth of life. Okay, let's suppose that the strength of gravity becomes stronger than the electromagnetic force. That is, let's suppose that gravity becomes stronger than the electromagnetic force by a factor of 10 to the 26th power. What would the universe look like then? In this case, the influence of gravity would dominate. Any structure of matter would be subject to the effects of strong gravity. Planets, stars, and even the electrons and atoms would be tightly collapsed together by the powerful effects of gravity, possibly even leading to a massive collapse of the entire universe. In other words, stars and planets would not be able to exist stably. They would merge too quickly because of too strong a gravitational force to form stable celestial bodies like the ones we see now. Even life may not be able to be born because the stability of atoms would be affected and the structure of matter could not be maintained. So how is it that this ratio of gravitational and electromagnetic forces is just right to keep the matter of the universe in such a stable state? Is it really just a coincidence? Perhaps it is, or perhaps it's not. Some scientists believe that the physical constants and natural laws of the universe are prerequisites for its existence. If these constants were to change slightly, then the structure of the universe and the formation of matter would become completely different. In other words, the ratio of the strength of gravitational and electromagnetic forces may exist precisely to ensure the stability of matter and the possibility of life. It provides space for the formation of stars and galaxies, while at the same time ensuring the stability of atoms and molecules in the microscopic world. But all this, again, seems so fortuitous, or rather, coincidental. If this ratio had been slightly off, perhaps we would not even be here today to discuss this issue, nor would we even be able to imagine the existence of life in the universe. Perhaps it is this fine balance that makes the universe a suitable place for life and complex structures. The famous physicist Paul Davies once said that the question of the fine-tuning of the universe not only puzzles scientists, but also gives philosophers and theologians a lot to think about. He believes that a small change in the physical constants is enough to destroy all forms of life in the universe, and that the combination of all these coincidences makes us question whether the universe itself exists for some deeper purpose, or whether it is simply the result of coincidence. Of course, there is no definitive answer to this question. It has prompted countless scientists and philosophers to ponder the origins of the universe and the meaning of life, but in any case, these precise proportions of forces have a profound impact on our world. It is for this reason that the universe is so mysterious and beautiful. 7. Structural coincidences in the spiral arms of the Milky Way galaxy. Have you ever wondered why our solar system is so just right? It's like you're traveling through a huge galaxy, and our solar system happens to be in a relatively calm spiral arm with few interstellar storms. Do you know how many spiral arms there are in the Milky Way? It's not just a huge galaxy, it's also a volatile place where stars move at high speeds and where cosmic storms, gas clouds, supernovas, and other dangers can erupt at any time across this vast expanse of sky. Our solar system, however, seems to be in a quiet place, no more, no less, just right. Why is that? First of all, let's talk about the structure of the Milky Way. Once you understand this, you will be able to appreciate how special our solar system's location is. The Milky Way is a spiral galaxy that is shaped like a large disk, with 4 main spiral arms extending outward and containing hundreds of millions of stars, gas, dust, interstellar matter, and more in different regions. These spiral arms are concentrations of stars and matter in the Milky Way and contain large numbers of young stars, nebulae, gas clouds, and other objects. Because these regions are densely populated with interstellar material and have relatively intense stellar activity, they are also often accompanied by violent astronomical events, such as supernova outbursts, stellar storms, and even sometimes black holes. There is a super black hole at the center of the Milky Way. The solar system, on the other hand, is now located between the Falcon Arm and the galactic transition zone. It's a relatively quiet region where we have spent the evolution of life on Earth. Okay, now back to the question, why is the solar system in such a relatively quiet place? You have to realize that the spiral arms of the Milky Way are not uniform, and their density of matter varies enormously. Certain spiral arms, such as the Falcon spiral arm where we are relatively sparse, containing few stars and relatively few gas clouds. Some of the more active arms, such as the Orion arm near us, are filled with young stars, nebulae, and sometimes even supernova outbursts. This is an environment of great uncertainty. Scientists have discovered that our solar system is located in a gap in the Orion spiral arm, a safe distance from the center of the Milky Way, not too close to the turbulent center of the universe, and not in the middle of a dense interstellar gas cloud. We live in a region where there are relatively few astronomical phenomena and the stars are farther apart, giving us a relatively tranquil cosmic space. Sounds a bit like manifest destiny, doesn't it? But it can't all be attributed to fate. The lucky position of our solar system is also the result of a long evolutionary process over time. In the early formation of the Milky Way, a large number of celestial collisions, gravitational force, and even the movement of gas clouds eventually led to the distribution of material in the different arms of the different differences in the distribution of material. This distribution of material resulted in the location of the solar system and the quiet condition we have today. There is even a suggestion that this chance may have been a key factor in the birth and development of life on Earth. If our solar system had been in a more violent region, our sun would have had more supernova outbursts, the surrounding stellar activity would have been more intense, and even some of the exotic interstellar material impacts would have destabilized the Earth. Perhaps we will not have the opportunity to sit and discuss these issues for a long time. But you know what? Not everyone thinks that the quiet location of the solar system is just a coincidence. In science fiction, the location of the solar system and the Earth is often thought to be an elaborate life preserve for some kind of superintelligent organism or extraterrestrial civilization. Although this sounds like a fantasy, some scientists have proposed a similar hypothesis. If there are other advanced civilizations in the galaxy, they may have the ability to select areas of the galaxy that are suitable for the birth of life. The location of our solar system could be the result of natural selection. The formation of the solar system and the location of its quiet zone may be the inevitable product of the evolution of the universe. In this case, life was able to be born in the right environment, develop, and even expand to other corners of the universe. Wouldn't you be a bit mystified? Because this position of the solar system does not only mean physical safety, it also means that during the long process of astronomical evolution, the Earth may have the opportunity to develop conditions suitable for life. In addition to the structure of the spiral arms of the Milky Way, the position of the solar system is also closely related to the motion of the Milky Way. The orbit of our solar system rotates around the center of the Milky Way, and it is not a perfectly circular orbit, but is slightly elliptical. Every 250 million years or so, our solar system goes through a galactic cycle, passing through the center of the Milky Way and crossing different regions of the spiral arms. During this cycle, the solar system crosses from one arm to another. Fortunately, our current position, i.e., not too close to the galactic center, is relatively smooth, and in our solar system's orbit, it avoids the more violent regions. Because of this, our solar system and the Earth have been able to develop peacefully, avoiding interstellar gas clouds and not too many external threats. Interestingly, this galactic cycle not only affects the position of our solar system, but it may also have an impact on life in our solar system. Some astronomers have even suggested that the traversing motion of the solar system within the Milky Way could have indirect effects on the evolution of life on Earth, such as contact with extraterrestrial material, or the effect of material in interstellar gas clouds on Earth's climate. 8. Observing cosmic coincidences. Simply put, there seems to be some unfathomable coincidence behind the fact that we seem to have appeared in the universe at just the right time, at just the right moment to be able to observe it most effectively. What is the optimal observing period that the universe gives us? In other words, why do we think that this is the best time for us to observe the universe? If you know a little bit about the history of the universe, you will know that the universe has evolved over a long span of time from the Big Bang to the present. Our now is a very special moment relative to the universe because many structures and phenomena in the universe itself have evolved over a long period of time, and it is only today that we can have a set of more mature tools, techniques, and ways of thinking to understand these phenomena. First of all, when it comes to the human ability to observe, you have to mention the development of our technology. Think back, if we had survived thousands of years ago, we would have been extremely limited in what we could see. Ancient people at that time could only distinguish a few constellations at most when they looked at the stars, and they didn't even have a clear idea of the shape of the Earth. Observations at that time were very limited and were often nothing more than myths or conjectures about the universe. But in modern times, our technology allows us to observe objects millions of light years away. Astronomy has evolved like a beam of light piercing through the haze over and over again. From the Hubble telescope to the James Webb telescope, JWST, these super telescopes have given us the ability to look at the universe like never before, to see more, farther, and deeper. As technology continues to advance, even evidence such as cosmic microwave background radiation, CMB, the faint radiation left over from the Big Bang, can be captured. It is precisely because we are in an era of rapid technological development that the universe just happens to be born at a time when it is most suitable for observation. From the perspective of the evolution of the universe, it is also interesting to note that we are here at this moment in time. The Big Bang occurred about 13.8 billion years ago, an event that marked the birth of the universe. Initially, the universe was so dense and hot that no light could penetrate it, and the whole universe was like a black box full of high-temperature, high-energy particles. About 380,000 years later, the temperature of the universe was lowered enough for atoms to form, and the universe became transparent. That is, light was able to travel freely. The cosmic microwave background, CMB, radiation produced at this time can be regarded as the first light from which we can observe the universe. This means that the evolution of the universe became visible at this time, creating the possibility of subsequent observations. However, if human beings appeared in this dark period, even if we had telescopes, we would not be able to see anything, and the universe would look like a blank slate. Looking further, the evolution of the universe has taken billions of years, with the gradual formation of galaxies, stars, and planets, and scientists and astronomers have been able to gradually unravel the mysteries of the universe. Now the universe, especially at our current stage of technology, is in a window of opportunity to see the remnants of the Big Bang, to explore planets, and to search for extraterrestrial life. So why does this timing coincide with the existence of human beings? Scientists have an idea called the window of observation theory. This means that the emergence of intelligent life forms such as humans is actually a very special stage in the evolution of the universe. In the early stage after the Big Bang, the universe is not yet stabilized. With the continuous expansion of the universe, the distance between galaxies will become farther and farther, and the propagation time of light will become longer and longer. And ultimately the universe will become more and more dim, and all the galaxies will be far away from each other, and the propagation of light will also become more difficult. Therefore, the existence of human beings and our ability to observe the universe coincides with a relatively short but extremely important time in the history of the universe, which is why we feel that this is the best time to observe the universe. Let's think about this again from the perspective of quantum mechanics. In quantum mechanics, there is a very classic proposition, the observer effect. Simply put, this effect implies that the act of observation itself will have an effect on the object being observed. So, if we look at it from this perspective, a philosophical question arises: is the universe itself suitable for us to observe, Or is the universe more observable because we are here at this moment? If we had not appeared at this time, we would not have realized the vastness and wonder of the universe. If we had appeared earlier in the history of the universe, we might have been in the Dark Ages, with no celestial bodies to be seen. And if we had appeared later, the universe might have already entered the expansion and cooling period, when all the galaxies started to cool down and all the galaxies began to be observed. If we had appeared later, the universe might have entered an expansion and cooling period, when all the galaxies began to move away and our technology could not capture any effective light signals. So, do these coincidences mean that the universe has somehow prepared us for this particular window in history? This question is not only a scientific but also a philosophical reflection. In fact, such coincidences are not just abstract theories. There are many real-life discoveries and stories to support them. For example, when human beings first observed celestial bodies with telescopes, they realized that the universe was so vast and the stars and galaxies were so far away, which made the ancient people's perception of the universe change dramatically. In the early 20th century, the famous astronomer Edwin Hubble discovered Hubble's law, which proved that the universe was expanding, and this discovery marked the beginning of a true understanding of the size and history of the universe. Based on Hubble's law, scientists began to speculate about the origin of the universe. The Big Bang Theory was born. These historic discoveries show that at a particular point in time, with the development of science and technology, we were able to capture the signals of the universe and gradually piece together the story of its evolution. Behind such discoveries, there are actually many coincidences. If human science and technology lagged behind for a few more decades, we might not be able to unravel these mysteries. This coincidence, which is closely related to the development of technology and the ability to observe, is one of the reasons why we believe that human beings appeared at the best time to observe the universe. Well, that's all for this episode. Welcome to like and comment. Thanks for watching.